Hey AP Calculus students, Mr. Record here. We are still dealing with section 5.2 out of the Larson textbook, and predominantly the topic at hand, if you're sort of new to the video series, is what to do in cases where you're integrating forms of 1 over x, or more specifically, in the general power rule sense, what to do when you integrate 1 over u where the du dx is present with respect to x. So that's what we're going to be dealing with here. And in this particular problem, I've titled the example when your normal U-Substitution doesn't seem to be a valid option. And what I mean by that is if you try to do some various things with selection of U, and I'm going to write some things that just flat out are not correct for this problem. So if you're copying along, you probably don't want to write the next few things down. But you know, it's very easy to want to say, well, maybe the u is the entire denominator. You know, it does sort of behave the way that this general integral is supposed to behave. But the problem with that is if we do take this derivative, and hopefully you all can tell that you would have to use the chain rule, although the chain rule really doesn't amount to much here since you're just multiplying by a 1. You come up with this 2x plus 2, I guess, this really binomial that really is not going to have any way of matching this 2x. Perhaps there are some things that we could do outside of the confines of Calculus AB to continue with this particular setup. But if you're an AB student, you're probably looking at trying to do this in a little bit more reasonable fashion. So I'm going to start from scratch and select a different u. Now I don't want to completely abandon the idea of letting u be something in the denominator, but if I do let u be, say, the x plus 1, we might be able to get somewhere with this. So I'm going to take the derivative of u, which is just 1, of course, and then I'm going to multiply the dx over here to the right. So I have du equaling dx. Well, it seems like that's just even worse. How are we supposed to match this 2x dx here with 1 times dx? They don't seem to be the same. And they're not. But that just means that we might have to be a little bit more clever with the way that we continue with this problem. So I'm going to go ahead and take a look at solving this u equation for x. So I would subtract 1 over to the left side. Well, at this point, we have some components here that we might be able to use to put the integral back together. In other words, we'll just substitute out things like the x, which is going to get replaced with u minus 1. I'm going to keep the 2 in front of it, of course. And then the denominator, which we knew is just simply a u to the second power, tells us something very important. We now have just one term in the denominator, a monomial denominator. And typically those things are quite easy to integrate. Now to finish this, we want to make sure that we substitute our dx out for du. That's going to be very important. And then we'll continue by perhaps bringing the 2 out in front of the integral. And then when we have u minus 1 over u squared du, we can then entertain the idea of splitting this apart into 2 separate fractions. U divided by u squared, of course, is 1 over u, and 1 over u squared is, of course, 1 over u squared du. Now we can let one of our new ideas take over. That is that the integration of 1 over u with respect to u is the natural log of the absolute value of u. And then we would integrate 1 over u squared. Now here we want to be careful. A very common misconception is that you can apply this integration formula in any scenario. And that just simply isn't true. In other words, this is nowhere close to being true. So you don't ever want to think about using that. Instead, in this particular instance, when you take the integration of u to the negative 2, that's nothing more than, when you integrate 1 over u squared, as I said, that's u to the negative 2. So you would just add 1 to the exponent, placing it also in the denominator. So this is kind of what we're wanting to put down here. And we could also kind of rewrite that a bit as negative 1 over u if we decide to do so. And then at this point, we are pretty much one step away from completing the problem, and that would be to back substitute. Remember in the original problem, u was equal to x plus 1 up here. So we're going to swap out our u and interchange it with x plus 1. And then we'll do something kind of similar here, although I'm going to take the liberty of changing the plus negative into a minus, and then our 1 over u could be 1 over x plus 1. You want to close out the parentheses since 2 was being multiplied by the results of both of those integrals. And then I can put my plus c at the end. And there you have it. That would be probably our best looking answer. And it is a pretty good example of a technique in integration called the change of variable method. Anyway, I hope this helps, and I'll see you next time.